All right. How you doing? I'm your man, John Wilson. Let's hope this video doesn't get corrupted like the last one so we can actually put it on the website. Today, we're moving to lesson 6.2 and 6.3. And as you can see today, we are going to understand how to derive characteristics used to describe functions and use tables, graphs, and equations to compare functions that relate to real-world scenarios and problems. Now, the first things first, we were dealing with functions. Today, we're going to start talking about linear functions. If you remember linear equations, when we were looking at a graph of a linear equation, what type of line did it have to have?
Straight.
A straight line. If it's linear, it has to have a straight line. Same thing with a linear function. If you graph a linear function, the graph must be a straight line. Well, let's say we don't want to graph it. Let's say, first and foremost, we just want to be able to look at the equation and determine, by looking at the equation, whether or not it's linear. To determine if a function is linear, we must remember that for a function to be linear, we must be able to write it in this form, which is slope-intercept. Y equals mx plus b. Notice that the m and the x form multiplication. Notice that there's a y-intercept. Notice that the y and the x are separated by an equal sign. Now, it doesn't matter if it's not directly in this form when you first see the equation. What matters is, 1, can I rewrite it into this form? 2, there can be no exponents greater than 1. 3, the slope and the x variable must present with multiplication. So what's happening between the slope and the x variable here? Multiplication. That must be multiplication. Also, last but not least, the variables x and y cannot be multiplied by each other. Same rules for linear equations apply here. So if we look at this first equation right here, is this linear, class? Yes or no?
Yes.
Yes. Let's examine. Let's go through the criteria. 1, can we write it in slope-intercept form? Yeah, it's already written in that form. 2, do we see any exponents here greater than 1? Yes or no? No, I do not. 3, is there multiplication between the slope and the x variable? Yes. And last but not least, are the y and the x being multiplied by each other? No. All the criteria have been met, which means that that is linear. Please write the whole thing. It's linear, it's in y equals mx, and this is supposed to be a plus. Let me just fix that real quick. This is a plus, little typos pop up from now time to time. That's supposed to be a plus. Crudely drawn, but just know that there's a plus there. Y equals mx plus b form. So this one's good. This one is linear. If I were to graph that, it would be linear. Let's go to, I'm going to set these up here just to make sure we get a good mix. Ali, it'll still be your question because I pulled your card. Ali, looking at the second equation, what do you think? Is that linear or non-linear?
Non-linear.
Non-linear. Okay, well let's examine here. We have a y, we have a equals. But then, after we have the numbers here, which could represent the slope, we have an exponent, x. Now, if I were to substitute in 1 there, would the exponent be greater than 1? No. But couldn't I substitute in anything for x? Couldn't I substitute in 2, 3, 4, 5, 6, or 7?
No.
I could. Can I make x anything I want? I can make x anything. I can make x a million. So because I can make this exponent into an exponent that's greater than 1, that ruins this criteria right here. There cannot be an exponent greater than 1. That defeats this equation right there and makes this non-linear. The exponent could be greater than 1, depending on what we substitute in. So that would be non-linear. Next one, Madison, MP, are you with me? Is this linear? Yes or no?
No.
No, why not?
Because it's not following the equation.
Well, y equals mx plus b. Now, what about this equation fails that test, the mx plus b?
It's not greater than 1.
Well, there is no, but that's not an exponent. So there's no exponents here greater than 1, so it passes that criteria. It passes this criteria. It passes this criteria. But what about this middle one? The slope, m, and the x variable must present with multiplication. What's this presenting with? Division. Since that's division, that's nonlinear. The slope is being divided by x. And as you're going to see, if we were to graph that, it would actually split the lines into 2 separate graphs. All right. Jennifer, not here today. All right, and Lucas. What about this one, man? What about this?
No.
Why not?
Because there's an exponent greater than 1.
Because there's an exponent greater than 1. As soon as you see that 2 there, that instantly tells you that is nonlinear. I have an exponent that is greater than 1. In fact, my exponent is 2. that makes it non-linear. Chris, what about the next one? Y equals 4. It's linear. This one is, in fact, linear. Can anyone tell me, follow-up question to that, what the slope is of this line? Anybody have an idea? Think about it before you just say it. What do you think, Hunter? What do you think the slope is? Slope's not 4. The y-intercept is 4. What do you think the slope is, Fiona? The slope is 0. Why is it 0? Let's look at this. Y equals 4. If I were to graph this, y equals 4, this is y equals 4, right? Y equals 4. But for it to be a line, I just need more than 1 point. Now, there's no variable here, right? There's no x variable. So I have to think, okay, how can I write this in y equals mx plus b form without changing the equation? What's the only thing that you can add to numbers or an equation that doesn't change it? 0. So I will simply add in my slope, which is 0, 0x, plus 4, which is my y-intercept, and now I can graph this. 0 slope is what type of line?
Horizontal.
A horizontal line. So if I were to graph this, it would be a horizontal line. Is that linear? Yeah, it is. Isn't that a straight line? Is that a curve? No, it's a straight line. This is a linear function. It's a straight line. It may be horizontal, but it's still straight. So this is, in fact, linear. It can be written in y equals mx plus b form, where m is equal to 0. Good job, Connor, and good job, Fiona. Last one right here. Ali. Am I going backwards to the cards?
Yeah, you don't.
I am, Connor. And Maldonado, sorry.
But that was my first question.
I know, but because I pulled your card, then I put you in the back by mistake. I was going the reverse order here. Maria, Maldonado. 2x plus y equals 4. Is that linear?
No.
Okay, well let's think about it. Let's think about the criteria. Does it have an exponent greater than 2?
No.
I mean greater than 1, so no. All right. Is there multiplication between the x variable and the slope?
No.
Yeah, there is. 2 times x, right? Isn't that 2 and x? Isn't that multiplication? So it passes this one, it passes this one. Variables x and y cannot be multiplied by each other. They're not being multiplied. They are being added. So it passes that one. You're thinking it fails because it's not in this form, right? Y equals mx plus b. Well, let me show you something. We have y equals mx plus b. And then the equation that I had was 2x plus y is equal to 4. So just pretend that this is an equation. We know that to move things from one side of the equal sign to the other, we have to do what? The inverse, right? Which is the opposite. So if I want to get y alone, I would need to get rid of this, right? What's the opposite of a positive 2x? So couldn't I just subtract 2x from both sides?
Wouldn't you have to divide it?
These would cancel. No, I'm not dividing it because all I'm doing is moving it. I'm just moving it from one side to the other. The only time I would divide it is if I'm trying to remove the coefficient from the problem. I'm not trying to remove the coefficient. I'm just trying to get this term onto the other side of the equation. And then what happens is, I bring down the y, the equals, and the negative 2x plus 4. Isn't that in the right form now? What's my slope? And what's my y-intercept? 4. And you're going to see when we get deeper into equations exactly why I can rewrite it like this. But do we agree that this is a linear equation, yes or no? Yes, it is. So this is in fact a linear, right there. Right? There we go. Linear. It can be rewritten into y equals mx plus b form. Alright, so does anybody have any questions on this whatsoever? Anybody? Alright, so let's see what it looks like when they graph, when we graph them. Alright, let's see what it looks like when we graph them. Now what I did here is I'm showing you the graphical version of all of these equations. We look at the first one here, 5.5x plus 7. Well, that's of course going to be a linear equation. The y-intercept is 7 and the slope is 5.5. And it's going to be a straight line, which makes it a linear function. But if we look at the next graph, this is the one where we had 5.5 times 1.02 raised to the x. It looks just like this. When we graph this equation here, as you can see, it starts out straight, but then as we change the exponent to 2, 3, 4, and 5, now the line starts to do what?
Curve.
It starts to curve. If you have a curved line, is that a linear function? No, that would be non-linear. See, it's not enough for me just to show you the equations, give you some rules. I want you to see exactly what they would look like when you graph them so you can understand visually why they're not linear. This is the one that is 0.5 divided by x. This is the one right here. And what happens is when you start substituting in values for x, if you plug in positive values, you get one graph. But if you plug in negative values, it actually splits into two separate graphs. You have one version graphed here, one version graphed here. That's the positive numbers, negative numbers. Obviously, it curves, it's not a linear function, and it's two separate lines. So there's no way this is there's no way this is linear. This is a non-linear function. It splits apart, they're curved. That's why it's nonlinear. What's up?
Can't we just look to see if the line is straight or not?
You could, but I'm showing you, we've already done these. We've already gone through these specific equations. I'm showing you what they look like when we graph them. So it's not just me giving you a list of rules. You can actually see exactly what would happen if we were to graph it. Why those specific equations are nonlinear. Okay? Rather than just saying, okay, here's the rules, let's show you exactly what it looks like. When we graph 7.5 x raised to the second power, whenever you have something raised to the second power, it's going to look like this. It's going to look like an upward or downward facing view. That's known as a parabola. You don't need to know that word, but this, once again, is that going to be linear?
No.
No, it's going to be non-linear. Obviously, it's not a straight line. And then when we graph y equals 4, what kind of slope does this line have?
0.
It's 0. It's a 0 slope. It is linear, but the slope is 0. It's a flat line, and it crosses exactly at 4 for y equals 4. So that would be a linear equation. And then the very last one was the one that we had to rewrite. We had to move over the 2x to the right side of the equation. We ended up with y equals negative 2x plus 4. That makes sense because we have a negative slope here, and it crosses over the y-axis at 4. Is that linear or nonlinear?
Linear.
That's linear. It's a nice, straight, juicy line. So any questions on this at all? Any questions on what a linear or nonlinear equation looks like? Sorry, function. Any questions? No? All right.
How do we know?
What? Okay. All right, so now we're going to move into graphing functions. The good thing is you already know how to do this. Now, when we graph functions, we must remember that inputs correspond to x values. Inputs are x values, and that means that the outputs correspond to my what? Y values. So y is here. Inputs are x values, outputs are y values. So if we're given a function rule, and we substitute in an input, what comes out the other side? An output. And when we put the input and the output together, what do we get? Coordinate pair. If I have enough coordinate pairs, means 2 or more, can I graph it? Yes, I can. So what we're going to be doing now is we are going to substitute in inputs into the rule to get outputs so we can then go graph the equation. When we run an input through the function machine and give it an output, we have created that coordinate pair. We can then go in and graph it. All you're doing is substituting in the inputs into the rule to get an output. Usually, your inputs will be given to you, but not always. If your inputs aren't given to you, what are you going to do? You're going to choose big numbers, small numbers? What are you going to do?
Big numbers.
You're going to choose big numbers, so you would choose like 1,648,212?
Yay!
Or would you just choose 0, 1, 2, 3?
I'll choose 1,300,000.
You would choose 1,643,000 and you would substitute that in, do all that math, when you could have just substituted in 0, 1, 2, 3? She's like, I'd substitute 0, 1, 2, 3. Let's just try simple numbers. We're going to take 0, we're going to substitute it in here. This is an input. So when we substitute it in, what are we substituting it in for? Y or x? X. This is an input, this is an x value, we substitute it in. And we're going to write 5 minus 2. The 0 is replaced, the x is replaced with a 0. And then what is negative 2 times 0? Anybody?
0.
0. Negative 2 times 0 is 0. What's 5 minus 0? 5. So if we plug in 0 and we do the multiplication and subtraction on the other side, we get a 5. And I have my very first coordinate pair. 0, comma, 5. Can I graph a line with just one coordinate pair? No. We want to have at least 2 And the true thing is, when you're graphing functions, you probably want to have 4 or more, so that way you can get a good idea of what the line looks like. So let's repeat the process. That is a 5, by the way. So now we're going to substitute in 1. Fiamma, we substitute in 1. What am I substituting in for? X. So we're going to write, tell me what I'd write.
5 minus 2 times.
Okay, and what is negative 2 times 1? Just Fiamma. Negative 2 times 1? Negative 2. And then what's 5 minus 2? 3. So we substitute in 1, we get 3 on the other side. And I have my next coordinate pair. And you're just repeating the process. Shimon, we want to substitute in 2. So tell me, what am I going to write? 5 minus 2. Parentheses 2. What's negative 2 times 2? Negative 2 times 2. Okay, what's 2 times 2?
4.
Okay, and a negative and a positive make a negative. So negative 2 times 2 is
4.
negative 4. And then what's 5 minus 4? 1. Okay, so when we substitute in 2, on the other side, we get 1. You? What?
Negative 4 minus, 5 minus negative 4.
It's 5 minus 4. That gives me
Yeah, but like on the left of what you did. Oh, no.
negative 2 times 1 is negative 2. Negative 2 times 2 is negative 4. All right. Connor, help me with the last one. What are we substituting in? 5
minus
negative 2 times
times
3. Okay, and then Connor, just Connor, what's negative 2 times 3?
-6.
Negative 6. And what is 5 minus 6?
-1.
Negative 1. So we substitute in 3, we get negative 1 on the other side. We have 3, comma, negative 1. Now that I have all these coordinate pairs, I can go in and I can graph the coordinate pairs. I can graph this function. Just to make sure we all remember how to graph things correctly, when we graph, where do I start? At what point do I always start? Origin. So I start at the origin. And Nolasco, you're going to help me graph the first ones. So we always graph the x-coordinate first. It tells me whether I go left or right. Then I graph the y. It tells me if I go up or down. So we're going to graph the first one. Am I going left or right? Am I going up or down? How many spots? 5. 1, 2, 3, 4, and 5. Right there. That's an important point. Anybody know what that's called? What's that point right there going to be called? It's my y-intercept. When I graph it, when I graph this line, that'll be my y-intercept. Viviana, next point. Tell me, am I going left or right? How many spots? What happened? 1 spot to the right, and then up or down? Up. 1, 2, 3. And that's my next point. Let me erase this little dot right here so you guys don't get confused. Okay. And, Drew, next point. Am I going right or left?
Right.
How many spots?
2.
Right 2, and then up or down?
Up.
Up. How many spots?
1.
1. Okay. And then the last one, Ms. Tavares. 3, negative 1. Am I going left or right? How many spots? 1, 2, 3. Then up or down? Down. How many spots? 1 spot. And I put my point right there. And once I graph the coordinate pairs, obviously I need to connect them with a what? Line. So we connect them with a line. Don't forget your arrows. I connect them with a line. I draw my little arrows at the end of either side to show that this line continues on even after I've stopped graphing it. Now, is this a straight line, yes or no?
Yes.
Yes, this graph is indeed a straight line, which means, there it is. Is this a linear function or nonlinear? What do you think?
Linear.
It's a linear function. It's a straight line. It's a straight line, linear function. 1, 2, 3. Sure. That's the other one. Good memory. So it's a linear function. Straight line, linear function. All you're doing is substituting in, get your coordinate pairs, you graph it and see if you have straight line or curved line. Straight line, linear function. If it's not a straight line, well, let's see what happens. So we have a new rule, x squared minus 2. Bolaños, we want to substitute in negative 2 into the rule. So tell me, what am I going to write?
Y equals
You can leave off the y equals. We don't need that, right? Okay.
2 times 2.
Well, negative 2.
Times negative 2.
Well, just write it in, write it in, and then we'll do the math in there. So it's negative 2 squared
minus 2.
minus 2. And then what is negative 2 squared?
Positive 4.
Positive 4, good. 2 negatives make a positive, so you have positive 4. When we square negative 2, guys, we'll get a positive 4, because 2 negatives always make a positive when we multiply or divide. So we're going to have 4 minus 2. What's 4 minus 2, Emily? 2. So we get negative 2, comma, 2. That's my first coordinate pair. And then, Rudy, negative 1. Tell me, what do I got to write?
Negative 2.
Hold on, we're substituting negative 1.
Yeah, okay, so negative 1.
Negative 1.
And then you put,
What does that mean? When you see that, what does that mean? How would I say that? I'd say negative 1
squared.
squared. Negative 1 squared minus
Minus
2. And then just, Rudy, what is negative 1 squared?
1?
1. Negative 1 times negative 1 is 1. And then what is 1 minus 2?
1.
What is 1 minus 2?
Negative 1.
Negative 1. So we substitute negative 1, we get negative 1 out the other side. So negative 1, comma, negative 1. None of this, once again, is new math. It's just simple substitution. Let's go to Maria Maldonado. We're going to have you substitute in 0. So tell me, what am I going to write?
You're going to write 0 to the second power.
0 to the second power, also known as 0 squared, same thing. 0 squared, or 0 to the second power, minus what?
2.
Minus 2. What is 0 squared?
0.
0, and 0 minus 2 is?
Negative.
Negative 2. Perfect. So we substitute in 0, we get out negative 2. Good. And Mr. Mota, I'm going to substitute in 1. Tell me, what am I going to write?
You're going to write 1 squared
1 squared
minus 2.
minus 2. What's 1 squared?
1.
1. And 1 minus 2 is?
1. Or negative 1.
Negative 1. So I substitute in 1, and I once again get out negative 1 on the other side. I have all 4 coordinate pairs. Now I have to go in and I have to graph them. So, Ali, help me with the first point. We're going to start here. We always graph x first, then y. I start at the origin. I'm graphing negative 2, comma 2. So am I going left or right?
Left.
Left, how many spots?
2.
Left 2 and then up or down?
Up.
How many spots?
2.
2. Okay, good. Miss Vega, next point.
Negative 1, left 1,
So left 1 and then
down 1.
down 1. Good. Okay. And Herrera Sean. Next point. What am I doing? Left, right?
Left.
Look at the x coordinate. What's the x coordinate?
Oh, down.
It's 0, right? So we don't go left or right. So we're just going to go down. How many spots?
2 times.
2 times. And it's right there. Okay. And then last but not least, Alicia, last coordinate, 1 comma negative 1. Am I going left or right?
Right.
How many spots?
1.
And then up or down?
Down.
How many spots?
1.
1. And we graph that point right there. Then, of course, we have to connect all of these with a line. So I'll start with my first point. And then we put little arrows there. Is that going to be a straight line?
No.
Obviously not. The line is a curve. The graph is a curve, which means that this is a parabola. And does that mean it's a linear function or nonlinear?
Nonlinear.
Non-linear function. I don't know why they weren't here today. So it's a nonlinear function. It's straightforward, guys. You're just substituting in coordinates to get coordinate pairs and then graph. And once you have the graph, it's visual. What's up? I owe you a ticket. I also owe Herrera Sean a ticket. I owe Alicia a ticket. I owe Ali a ticket.
Thank you. You don't know us? You
I don't owe Slamtana a ticket. Excuse me, poor Sorry, copy.
That's even worse.
What's up? I owe you a ticket too. Mariana Sierra II. Also known as Maria Maldonado. That's actually what's 11?
You already gave me go.
Oh.
Okay, never mind.
Oh.
And what?
That actually was her seat too.
Oh my god, no.
Yes. Alright, 4, 3, 2, 1 on this. The distinction there. Alright, so moving on. Now we're actually going to be comparing functions of 2 different types. First thing we're going to compare is a table and an equation. Now the good thing is you already know how to write these functions. How many of you remember how to find the m from a table? What's the m represent?
Slope.
How many of you know how to write the b once you have the slope? And what does the b represent?
The Y-intercept.
Also known as the initial
Value.
Okay, so if we look here, we want to compare a function written as an equation and another function represented by a table. The first thing that we're going to have to do is go in and find the equation for this table. Stop. What you want to do is you want to read the scenario. It says Brandon and Max download music from different services. The monthly cost, Y dollars for X songs, is linear. Okay, so we know it's linear. The cost for Brandon to use iTunes is represented by this function. This is where you actually have to go and do that thing that you guys love to do so much, which is actually reading the word problems, identifying what it is they're asking you to do. The cost for Max to use Google Play is shown below in this table. So do I already know one of the equations here, yes or no?
Yes.
For who? Chris, who do I know the equation for? Max. I know the equation for Max? No. Max is the table. Who do I know the equation for? Brandon. So I know Brandon's equation. So what I'll do is I'll just write Brandon's equation down here, and I'll come back to it. Later on, I'm going to have to evaluate this. So 1.25x plus 10. I know Brandon's equation. To be able to compare Brandon and Max, I need to write an equation for Max. To do that, I have to find the slope and the y-intercept. Looking at this table, let's go to Sebastian. I want to write an equation for this table. So I need the m and the b. Help me find the m. What are you going to use? What coordinates are you going to use?
21, 8, 21.
8, 21.
And 5, 16.
And 5,
16,
comma,
0.50.
16.50. Let me ask you a question. When presented with choices, you could use whatever you want, but we're presented with choices that include decimals or whole numbers, what would be easier for you to choose? Probably the whole numbers, right? Less ways to make mistakes. If I were given this table, even though we could use any set of coordinate pairs, I'd probably use the 2 sets of whole numbers. They may not be the smallest ones, but less room for error. So I'm going to use 14, comma, 30. By now we should know how to do this, I don't know, just by looking at the problem. Brianna, tell me, what am I writing in the formula? We're going to use a slope formula here, so what goes in?
21 minus 16.5.
Oh, you use the other coordinate pairs? Let's use these coordinate pairs. Okay. What would you write?
30 minus 21.
30 minus 21 over
14 minus 8.
14 minus 8. What's 30 minus 21? 9. And then just Brianna, please. What's 14 minus 8? 6. Now, normally we would just simplify the fraction. But because we're talking about dollars and cents here, we need to turn this into dollars and cents. So, anybody tell me, what is 9 divided by 6? Anybody? Anybody? 9 divided by 6? 1.5. So the slope here is going to be 1.5 or $1.50. That's my slope. $1.50. Now I need to go back and I need to find the y-intercept. So to find the y-intercept, we write our equation, y equals mx plus b. And then I have to identify a set of coordinates to use. Corey, what coordinate pair do you want to use? We're trying to find a b now.
Doesn't the m go as 1.50?
Well, first let's figure out what coordinate pair. What coordinate pair do you want to use to help you find b?
16.50, 5.
Oh, well, first of all, it would be 5, 16.50. It's always x, y, right? But the same thing I said before, given a choice between decimals and whole numbers, what should you probably choose? The whole numbers, right? Because they're easier, less room for error. So, which coordinate pair do you want to use?
8, 21.
8, 21. So we'll use 8, 21. 8, 21. Actually, let me move this over a little bit, just so we have room. So we're going to write y equals mx plus b, and we're going to use 8, 21 and the slope. All right. Lucas, what goes in for y?
8. Wait. No, 21.
21. 21 is my y. That goes here. 21 is equal to, and what's my slope, guys?
1.5.
1.5. We can just write 1.5. We don't need the 0 here. 1.5 times what?
8.
8. Good job. Plus b. And anybody tell me what is 1.5 times 8?
12.
12. So we get 21 is equal to 12 plus b. What do I do now?
Subtract.
I subtract 12 from both sides. Subtract 12, subtract 12. E's will cancel, and I get 9 is equal to b. So now, can I write my equation for max? Yes or no?
Yes.
And what's the equation for max?
It will be 1.5. 1.50x
1.50x
plus 9.
plus 9. Okay, so we have both equations. Now that I have both equations, I can move on to the second set of problems. And the second set of problems is, now that we know the equation for both Brandon and Max, let's see whose service is cheaper if 30 songs are downloaded. So looking back at the table, we're being asked to talk about songs. We're being asked to figure out a problem that involves songs here. So if I look at the table, what is songs? Is that x or y, guys? X. So when I substitute in 30 into this equation, obviously I'm substituting it in for x. So let's do that. Let's figure out who is cheaper. And I'm going to write 1.25. The x is removed and is replaced with what? What's it replaced with?
30.
30. Plus 10. Anybody know what 1.25 times 30 is? Yes?
300.
It's not 375. It's 1.25 times 30. Anybody have an idea? Yeah? 37.5. Don't forget to add the 10, and I'm going to get $47.50. So that's how much it costs for Brandon to download 30 songs. Now we're going to go figure out Max. Shimon, where's the 30 go? X. So 1.50 times 30 plus 9. What is 1.5 times 30? Anybody? I'll help you out. It's 45. 45 plus 9 gives me 54. So $54. Who is cheaper, Brandon or Max? Brandon was cheaper by about $6.50. So Brandon
Why did you say
cheaper. Why not use 30? If we look at the second problem here, it says now that we know the equation for both Brandon and Max, let's see whose service is cheaper. If
Oh, I didn't even
30
see that.
songs are
I
downloaded.
didn't
Now,
even see that.
tiny little thing right down there, but it's $54. It's heading away down.
That's a lot.
All right, next thing, and I'm going to go off camera for this for a second. Guys, if you have calculators, and you all should by now, you need to take them out. Who has a calculator that has not taken it out yet? Please take them out. Take out your calculators. You need this because we're going to be doing the numbers. Most of you are not going to be able to do this in your head. Chris, you got a calculator? I don't have one, unfortunately. Someone borrowed it and didn't bring it back. I'm waiting to see them next period. Corey? Nope. Remove the arms. Thank you. All right. Let's try another one. A cell phone company offers 2 texting plans to its customers. The monthly cost, Y dollars of one plan, is Y equals 0.10x plus 5, where X is the number of texts. So it tells me X is the number of texts. The cost of the other plan is shown in the table. So what we're going to do is we're going to say we have 2 plans. We have plan A, we have plan B. Plan A is going to be represented by this equation. Plan B is represented by the table. So I want to go ahead and I want to write the equation for plan A down here. I'm going to take it out of the problem. I'm going to write it down here. And that's going to give me just a rule. I don't want the whole thing. 0.10x plus 5. Now I need to go get the rule for plan B, and then I'm going to need to compare the functions at 1,000, because I'm being asked which plan is cheaper for 1,000 texts. In order to answer that question, I need an equation for plan B. So, for plan B, Bolaños, I want to find the slope for plan B. What coordinate pairs do you want to use?
20, 100, and 25, 200.
Okay, why are you saying 20 first? Is it because it's the smaller number? Doesn't x come before y?
Oh yeah, 100, 20.
100, 20. Don't worry, that's a common mistake. We always think the smaller numbers are going to be our x. It could be either or. So 100, 20 and
200,
200, 25. So now we need to find the slope here. And I'm gonna go to Rihanna again. And I'm gonna grab those cards. Oh, right there. Alright, Rihanna, help me find the slope. What is gonna be my y2? 25 minus 20 over 200 minus 100. And what's that gonna give me? 5 over 100, which when we divide this is going to become 0.05. So we found my m. It's 0.05. Now I need to go in and I need to find the b. Let's go to Yama. Want to find the b. So tell me what equation I'm going to write. Y equals mx plus b. What coordinate pair do you want to use? 100, comma, 20. What goes in for the y? What goes in for the y? 0.05 is the m, right? So what goes in for the y? 20. 20 is the y value. So 20 is equal to 0.05 times 100 plus b. Anybody tell me what 0.05
5.
times 100 is?
It's 5.
It's 5. So we 20 is equal to 5 plus b. What do I do now, class?
You subtract it.
Good. Subtract 5 from both sides, and I get 15 is equal to b. So I have my m, I have my b. I can go in and write the equation for plan b, and I'm going to have 0.05 x plus 15. That's plan b. So, do you understand how we get the equation for plan b? Yes or no?
Yes.
Yes. We have the equation for plan a. So what do I got to do now? What do I actually have to go and do now? What does it say? What did I circle up there in pink? What do I need to do? It says, what does it say? Which plan is cheaper for 1,000 text messages? Now, looking at our table, I need to figure out, okay, text messages, is that X or Y? So looking at the table, is text messages the input or the output? It's the input, which is the X value. So text messages is my input, cost is my output, which means that when I'm substituting in 1,000, I'm substituting that in for X. And we're going to substitute it in just like this. 0.10. The X is removed, and what do we replace it with, class? 1,000. Plus 5. What is 0.10 or 0.1 times 1,000? Anybody? It's 100?
Yeah.
Good. 100 plus 5, which means that plan A for 1,000 text messages will cost you, dollars and cents, $105. Okay. That's a lot of money. Let's see, maybe plan B is cheaper. Miss Tavares. Yeah. Want to substitute in here. So tell me, what am I going to write?
0.05. No. Yeah.
Parentheses.
1,000.
1,000 plus.
15.
Okay, and then what is 0.05 times 1,000? Just her, please.
$50.
50, good. So we get 50 plus 15. We add that together, that's going to give me $65. So which plan is cheaper for 1,000 text messages, guys? Plan B. When in doubt, use plan B. Plan B is cheaper. By the way, that says plan B is cheaper, but you can't see it. So the thing is, this is not difficult. Is any of this new math? Is any of this new? Nope. No, isn't this all stuff we've done before? But now the numbers are a little trickier because now you're working with decimals, stuff like that, and you have to substitute in and solve. It's multi-step. It's really just a lot of work. But once you get used to it, you'll see that it's actually going to go much quicker than you think. So, any questions on either of these? Any questions? What's up? How come the 25 minus 20 is fine? Because these are the y values. See here, y values 20 and 25. Isn't that y2 minus y1? I know the thing is a lot of times we get so used to, okay, the bigger numbers on top, smaller numbers on the bottom. The truth is the y's can be anything, the x's can be anything. In this case, the y's were smaller than the x's. So on the top, we had smaller numbers. On the bottom, we had the bigger numbers, which would give us a decimal or a fraction. Okay? Any other questions? Okay. Fourth. All right, one last section to go. Now we're going to compare a table and a graph, and then once we do that, we're going to compare a graph and a description, which is actually the easiest thing to do as long as you remember certain key words. First, though, let's compare a table and a graph. So the same thing happens here. Just like before, when we had to look at both equations or both rules, we're going to do the same thing here. The difference is I have no rule here and I have no rule here. I have to go in and write a rule for both of them. The situation says the table and graph show how many words Morgan and Brian type. This is Morgan's typing speed. This is Brian's typing speed on a typing test. The time is linear. And what we need to do is we need to go in and we need to write a rule for Morgan, we need to write a rule for Brian, and we need to see who types faster. So I want to write a rule for Morgan from this table. Since we've already done this, I'll speed it up for you a little bit. We're going to pick two coordinate pairs. Please follow along on your paper. I'll use 2, 30 and 4, 60. These will go into the slope formula. As a class, you can tell me what goes where. What am I writing?
60 minus 30.
60 minus 30.
4 minus 2.
Over 4 minus 2, that's going to give me 30 over 2, which means my m is equal to 15. So I know the m. I got to go back and find the b now. So I'm going to write y equals mx plus b. And I'm going to use 2, 30 as my coordinate pair. What goes in for the y, guys?
30.
30. 30 is equal to 15 times 2 plus b. Do we understand how we got there, yes or no?
Yes, sir.
Yes, we do. 30, that's my y, that's my slope, that's my x. What's 15 times 2? 30. So we're going to get 30 is equal to 30 plus b. Those two 30s are going to do what?
Cross out.
Cancel out. Minus 30, minus 30. My b is equal to 0. So my b is equal to 0. What's my equation going to be? What's my rule going to be?
Y equals 15.
Y equals 15x. Y equals 15x. Now, I need the rule for who?
Brian.
Brian. So I need the rule for Brian. Looking at the graph, is this a proportional relationship, yes or no?
Yes.
Yes, it is, because the line goes through the origin. It goes through origin. It goes through 0, 0. So I know just because it goes through 0, 0, do I already know my y-intercept, yes or no?
Yeah.
What's the y-intercept? 0. Because it goes through the origin, my y-intercept is 0. That's done. Now I just need to find the slope. The good thing is, do I or do I not already know one of the coordinate pairs?
Yes.
What coordinate pair?
0, 0.
0, 0. I know one coordinate pair. I just need to find another one. So I got to look real close. I got to find a lattice point. And it looks like this is going up by 20s, 20, 40, 60. And it looks like it crosses through here. That's going up by 1. So my other coordinate pair is going to be 1, 20. Now this goes in the slope formula. And we're going to have 20 minus 0 over 1 minus 0, which becomes 20. So my slope is 20, my b is 0, my equation is y equals 20x. Now that I have the equations for both of them, I need to figure out what? The question is, which student types more correct words per minute? So to evaluate this, what am I evaluating at? What number? How many minutes?
1.
Yeah, somebody said how many minutes? 1 minute. It's per minute, which is, when I say per minute, how many minutes are we talking about? 1 minute. So we have to evaluate it at 1. Which actually, I don't have to do much. What's 15 times 1?
15.
15. So Morgan is 15 words per minute, correct words, and Brian is 20 words per minute. So who's faster? Who has more correct words?
Brian.
Brian. then you can write more correct words. So Brian is the winner of this competition, yeah? More correct words, and he is the winner. He has 20 correct words per minute, and Paul Morgan is left with the dust. And this problem is done. And look at all this, very sensitive. And then I have to go and erase all this. Ah! Mostly you're like, no! Okay, whatever. People like look at this, the notes here, and like, what is that? Is that the Sanskrit alphabet? I have no idea. All right, so any questions on this one? We got one more to go. So this is table and a graph. What if we have a graph and a description? Further descriptions, the good thing is you've already been taught this. Looking at this situation, it says Aisha runs a tutoring business. With plan 1, students may choose to pay $15 per hour. With plan 2, they may follow the plan shown on the graph. So the graph represents plan 2, and this represents plan 1. Looking at this situation, do I see any keywords that indicate change there? Yes or no, Sean?
Yeah, per.
Per indicates change. So my slope here is going to be 15. What's my y-intercept though? It's 0. Let's think about this in a real world context. Why is it 0? It says she charges them $15 per hour. $15 per hour, that's it. There's nothing else there. She doesn't say anything about a fee for plan A. She doesn't say anything about an initial startup or registration, nothing. All you're doing for plan 1 is paying $15 per hour. So you write this out as y equals 15x. It's just that simple. No y-intercept. If you're not getting tutored under plan A, you're not paying anything. Now I have to go and I have to look at plan 2. Looking at plan 2, Ms. Tavares, we want to look at plan 2. Do I know the y-intercept for plan 2?
Yes.
What is it?
40.
40. So I know my b is 40. I look at the graph, I see where it's going to hit the y-intercept, and it's going to hit right there. Now I need to go in, I need to find my slope. So I have to find another lattice point. This is going up by 1. So 1, nothing there. 2, hey, there's 1. And it looks like at 2, 50 is another lattice point. So I write my 2 coordinate pairs. What's the first coordinate pair I'm going to write? 0, 40, the y-intercept. That's the easy one. And then 2, we always check it again just to make sure. 2, 50, that's good. 2, 50. Now I go in, and I do my slope formula, which is going to be 50 minus 40, y2 minus y1, over 2 minus 0, and that gives me 10 over 2, which is equal to 5. So the slope is 5, the y-intercept is 40, my equation is y equals 5x plus 40. That is a 40, let me fix that. So it looks like a horribly drawn 9, 40. Okay. So I have the equations for both of them. What am I supposed to compare these two things at? What number? Yeah? What is it?
Which is cheaper than 20.
Which is cheaper for 20. So I'm going to compare these two for 20 hours. What is 20 hours? What is hours? Is that x or y? X. And in case you're unsure, look at the graph. X-axis, that's my input, time in hours. So I need to substitute in 20 into each of these equations. Here, I'm going to do 15 times 20, which gives me 300, okay. So we know that 20 hours under plan 1 is $300. Now 20 hours under plan 2 is going to be 5 times 20 plus 40, which equals, anybody? 140. So which plan is cheaper for 20 hours? Plan 2. Plan 2 cheaper. Any questions? Once again, everything in here, like I said at the beginning of this, there's only one small section of Module 6 left. We're just about done with Module 6. Which means that we're going to be moving into Module 7 on Friday. On Wednesday, we're going to finish up Module 6. We're going to take a very small exam. Not going to be a lot of problems on. Right now, does anyone have any questions at all? Anybody? Okay. 4, 3, 2, 1.